Hey, wanted to tell you guys a bit about exponents today. So what we're going to do is we're going to jump into how to simplify exponents and exactly how the rules and laws of exponents work. So let's jump right into it here. So one of the first things you need to understand about exponents is what they are. And so if I look in the expression like a to the power of 5, what I can think about is that right there is really a times a times a times a times a. These two things right here are equivalent to each other. Now, this right here is an expanded form, right? And really, the expanded form is never used. It's only really there for us to just kind of understand how exponents work. We never get an answer in expanded form unless it's explicitly asked for. It is not simpler than a to the power of 5. It's just another way of writing it. And so what we can do is we can simplify exponents using some of our laws of exponents that we've talked about already. Let's jump down into the laws of exponents. So one of the first laws of exponents is how we put together things that are being multiplied by each other that have the same base. Now, we didn't talk about what a base was, but this right here is the base. And this up top is the power, or the exponent. And so if the bases are the same, what we can do when they're multiplied together, we can add those exponents. So like right here, when we have x to the power 3 times x to the power of 4 is equal to x to the power of 7 because we added 3 and 4. Same thing over here. If we have a negative exponent, we would add it to the positive exponent of 5, and we get a solution that is 2, our common base, to the power of 4. All right, there's our first law of exponents. Our second law of exponents is if we divide. And so again, we have to have the same base. In this case, the base is x. And if we're dividing, we have that a up top divided by x to the power of b. We're going to get x to the power of a minus b. We're simply subtracting the two. So in this case over here, the examples that we run are x to the power of 10 over x to the power of 6, which gives us 10 minus 6, or 4. Same thing over here, but we have the bottom, a larger exponent. So that means it's going to end up being 4 minus 7, which is a negative exponent. We'll talk more about negative exponents in just a little bit. So here's a little bit more. We have a power of a power. So when we take a power of a power, we're going to get the multiplication of those two exponents. So when we have x to the power of 5 to the power of 3, we get x to the power of 15, which is multiplying those two together. Same thing over there with the numbers. Then another definition kind of that we need, or a law of exponents, is anything to the power of 0 is always going to be equal to 1. It doesn't matter if it's a variable or if it's a number, it's always just equal to 1, as long as it's not 0. Then our negative exponent. The definition of negative exponent is really 1 over that thing. And so if this was an x to the power of negative 1, it would be 1 over x to the power of 1. Our x to the power of negative 2 would be 1 over x to the power of 2. Same thing with a numbered response. 3 to the power of negative 1 is going to give us 1/3. Let's run through a couple of examples that kind of highlight those laws of exponents. Our first one right here is adding. All right, so we're going to get x to the power of 7 plus 4, which is x to the power of 11. The next one that we get right here is going to be, let's go another color right here. We have a power of a power. So that's going to be x to the power of 3 times 3 now. So x to the power of 9. Here we have the same base, m. So that's going to be m to the power of 14 minus 2. So that's m to the power of 12 as we simplify it. When we get a little bit more complicated, we want to do things kind of one at a time. So this right here is powers of powers. So that's going to be x to the power of 2 times 4 and y to the power of 2 times 4. So that's going to be x to the power of 8, y to the power of 8. Nice and simple on that first one. You just have to apply it to both of them. Now, here's where I like to separate things out. So if we have x to the power of 5, and I have x to the power of 2. I'm going to think of those as being the same kind of thing. Same with my y's. I need to group them together and talk about them individually. So here we have x to the power of 5 over x to the power of 2. So that's going to be x to the power of 5 minus 2, which is x to the power of 3. By the way, you do not need to write that middle step. It's just explaining what's going on. Over for the other one, we're going to get y to the power of 11 minus 3, which is y to the power of 8. And so this becomes our answer right here when we put them back together. You can put a multiplication or it's implied really right there. The next one we have is one with both numbers and variables. So let's take a look at the numbers first. We have a 2 and we have an 8. Now, the important thing to remember is that's really just 2 divided by 8. And 2 divided by 8 can be reduced, and it's equal to 1/4, right? Then we have the numbers, sorry, the variables, 2 to the power of 12 and 2 to the power of, x to the power of 12 and x to the power of 2, which is going to give us x to the power of 12 minus 2, which is 1/4 times x to the power of 10. Now the x to the power of 10 is going to go on top, and the 4 goes on bottom. That's some of the examples that we have for simplifying exponents or simplifying expressions with exponents. Now again, rules of negative exponents. If we have something that has a larger power on top than it does on bottom, it's going to give us that 5 minus 7, and that's going to give us x to the power of -2. Now, going back to the original, if I would have broken this up as x times x times x times x times x, we kind of see what the definition of this is and how there are 2 more x's on the bottom than there are at the top. So if we were to cancel it out, we get this idea that this is really 1 over x to the power of 2. And that's how we get from here to understand that it's really just an answer of 1 over x to the power of 2. Just as a rule, we always want to express answers in positive exponents. Positive. So even though this one is not wrong, we always want to write it as 1 over x to the power of 2. All right, let's take a look at a couple harder problems that have a little bit more to do or more to going on, and then we're going to get into scientific notation. Again, when we look at these, I got numbers, I got numbers. Then I got variables that are the same, and then I have a variable that's different. I want to start right here with something that's important, that y to the power of -1. Now, remember up here when we had x to the power of -2, we brought it down to the bottom to make it positive. Well, in a new example right here, we could have the same thing as, say, like a to the power of -5. Well, if something is to the power of -5, I'm going to end up moving it to the top. So if it's on the top as a negative exponent, it moves to the bottom and becomes a positive exponent. Same here, a to the power of 5 is going to go up top, and now that's going to be our exponent. All right? So when we have a negative exponent like this, we can move it up to the top and make it a positive exponent. So I'm going to have on the top of this fraction, y to the power of 1. Now, I don't need to write the 1, but there it is. Now I have these two right here, x to the power of 2, x to the power of 5. I don't need to do the subtraction because I know x to the power of 3 is going to be what is left, and it's going to be on the bottom. If I did subtraction, it would be x to the power of -3, and then we'd move it to the bottom anyways. Now we have the 18 and the 30. Now I'm looking for something that cancels out in those two. A 6 can cancel out in both of them. So 18 is really 6 times 3, and 30 is really 6 times 5. So I can cancel out the 6's, and I'm going to be left with 3y over x to the power of 3. Ooh, I forgot my 5. 5x to the power of 3. There's nothing more that can simplify, so we're just going to leave it as is. Let's take a look at the next one here. Again, I'm looking at the things that are like each other, so I want to group the like terms. So now I can put the x's together, and same thing with the y's. And so we just match them together. 5, or negative 5 times negative 2 gives us positive 10. X to the power of negative 2, x to the power of 3. We add those, we get x to the power of 1. And then y to the positive 1, y to the negative 2, that's y to the power of negative 1. So when I rate this, I'm going to drop that y down to the bottom. And there's my answer. Last example that we have right here, I try and cancel anything out that I can. So I see that 15 and I see that 45. And then I look at the x's and the x's. The 15 and the 45, well, that's just 15 over 45, which is equal to 1/3. And then the x to the power of 2, x to the power of 3, those are on the bottom. So that's going to be x to the power of negative 1. But when it is a negative, it's then going to turn into x to the power of 1 on top. So now I have x over 3, and that's going to be my answer right there. All right, last thing we have here is scientific notation. In scientific notation, we always write things between 0, or really, sorry, between 1 and 10. So if I was to write something in scientific notation, a random number like 7.3 times 10 to the power of 6, that'd be totally great. We could do that. That's in scientific notation. But if I wrote it like 0.83 times 10 to the power of 5, that would not be in scientific notation. That one would not be in scientific notation because it's not between 1 and 10. All right, so let's look at these. We're going to combine them and then put them in scientific notation. Again, we have numbers that we can combine together, and then we have 10 to the power of somethings that we can combine together. I'm going to put together my 10 to the power of somethings and get 10 to the power of 8, adding them together. And then for my numbers, I get 6 times 3.2. And so if I do 6 times 3.2, I'm going to end up with a number that's greater than 10, 19.2 times 10 to the power of 8. Even though that's a correct answer, it's not in scientific notation because I need to move this decimal point between the first and second digit because I need it between 1 and 10. When I do that, since I made the number smaller, I'm going to make the power bigger. And that's my answer. Last problem we have right here, same thing as before, numbers, and tens. The numbers, we have 1.2 over 4.8. That right there, it could reduce down to 1/4, but we can also reduce it down to 0.25 because that's what 1/4 is. Right here, we have -6 minus -3. So that's going to be times 10 to the power of -3 when we put those together. Now, this is also not in scientific notation. We need to move this over 1. And since we're making that number bigger as 2.5, we're going to make the variable smaller. All right. So that's some of the ideas that we have with exponents and how to work everything through. I hope that helped you out, and I hope you all have a great day.